Hi, it's Karen Gregorian. In the previous video, I showed how we can add visible connections to the World Wide Web. If you haven't seen it, you should watch it first, because this video builds directly on those ideas. Those ideas were inspired by Ted Nelson and his long-running project, Project Xanadu. Since the 1960s, Nelson has been trying to build a system similar to the web as we know it today, but much more powerful. Over several decades, there were multiple attempts to implement it, but for various reasons they never fully succeeded. Eventually, the World Wide Web appeared and became the dominant platform. In the previous video, I argued that some early design decisions made the web hostile to many of Xanadu's core ideas. Visible connections between documents are one example. My project is an attempt to bring some of those ideas into today's web. At the moment, the implementation is intentionally simple. It introduces a new kind of web page and one-way, hash-based floating links. In that sense, it's a simplified version of some Xanadu concepts. But once we see that visible connections can be added to the web, even in a simplified form, an obvious question appears. What other Xanadu-inspired features could we bring to the web? Let's explore this question. This video has two parts. In the first part, we will look at what Project Xanadu was, how it differed from the World Wide Web, and then examine some of its key features in more detail, such as stabilized content addresses, versioning, Xanalinks, transclusions, its overall addressing system, transcopyright, and two-way links. In the second part of the video, I will share my ideas about how those features could be brought to the modern web. So, what was Project Xanadu? Most people who know about Project Xanadu will probably say that it was something like the World Wide Web, but more complex, and that it ultimately lost to the web. And if you ask why Xanadu failed while the web succeeded, the usual explanation is, Xanadu lost because it was complex, the web won because it was simple. There is some truth to that, but it's not the whole picture. There is a categorical difference between the two systems. They are not just different versions of the same thing. They were trying to solve fundamentally different problems. Ted Nelson was trying to create a new kind of literature using computers. In other words, he was trying to create a literary system. The word literary may sound a bit belletristic, but here it simply means something focused on text content. Any piece of writing, an article, an essay, or a blog post could be part of such a system. The goal is to create a system where texts can reference, quote, and connect to one another in meaningful ways. Tim Berners-Lee, on the other hand, wanted to create a global network of linked documents. To build a global network of documents, you need two things: an addressing system and a universal method to retrieve resources. That's exactly what he created. He invented URLs that can address any resource on the web, and he created the HTTP protocol, which defines how resources are requested. There is nothing wrong with those two things. You'd need something like them anyway, no matter what web architecture you use. But when it comes to connections between documents, Tim Berners-Lee chose the simplest possible solution, which is hyperlinks embedded in the text. These links connect documents, not specific pieces of text. There are no visible connections, no transclusions, just hyperlinks. In practice, we ended up using the web as our literary system. But because of the features it lacks, as a literary system, the web is actually quite limited. To summarize the difference between the two systems, we can say that Xanadu is for literature, while the web is for everything. Again, I use the word literature here in a broad sense, meaning all kinds of written material. Because Xanadu is more specialized, it can be much more powerful when dealing with text. To see how the two systems relate to each other, let's do a thought experiment. Imagine that Xanadu had won. Let's say Tim Berners-Lee never created the World Wide Web. We would have a literary system, but sooner or later, someone would create something else on the internet, another system designed for a different purpose. For example, an e-commerce platform. Then someone else might create a hotel booking system, then another specialized system for something else. In fact, this is very close to how the Internet actually looked before the web, a collection of separate systems, each with its own way of accessing information. Eventually, someone would look at all those separate systems and say, "Look, we have all these independent systems. Wouldn't it be nice if there were a single addressing system and a standard way to access any resource on the Internet?" And something very similar to the web would probably appear sooner or later. That's why I think of the World Wide Web as inevitable. And because the web has to include everything, not just literature, it has to be bigger than any individual system, but also less specialized. And that means it can't handle texts as well as a system designed specifically for them. So if we want to build something like Ted Nelson's Xanadu, we have to build it inside the web. It can't replace the web. It can only exist as part of it, potentially a large part, but never the whole thing. Now let's look at Project Xanadu in more detail. How was it supposed to work? To understand it, we can start with its core idea. Quotes should be visibly connected to their sources. Once we accept that idea, an immediate question follows. What happens if the source document changes? By trying to answer that question, you can essentially reinvent Project Xanadu. As a side note, if the source document is just an existing web page, we can use the approach I described in the previous video. In that case, we rely on floating links with hashes. If the content changes, the link may detect that it's broken, and in many cases it can even locate its new position in the text. But that's not the approach used in Project Xanadu. In Xanadu, all documents are part of the same system, and they cooperate to ensure that links never break. Documents don't simply change their content in arbitrary ways, so let's see how that system was designed to work. We will start with stabilized content addresses. Their purpose is to ensure that floating links never break. As an example, imagine that there are two empty documents on our server. We also have a content file, which is empty as well. The content file is never shown directly to users. People can only request documents. Now let's say we want to add some text to document A. Instead of storing the text in the document itself, we add it to the content file. The text is 101 characters long, so it occupies the range from index 0 to index 100 in that file. We then record that range in document A. In fact, document A doesn't contain the text itself. It only contains the range. What is marked as Document A on this image is just a visual representation of Document A as it would appear on the screen when you open it. In reality, the document only stores the range. When you open it, the system first retrieves the record that contains the range and then uses that range to request the corresponding text from the content file. Let's mark the things that are actually stored on the server in yellow. Everything else is just a visual representation to help us understand how the system works. Now let's say we want to add some text to document B. Again, we add the text to the content file and then store the new range in document B. Now suppose we want to add more text to document A. Once again, we add the text to the content file. But this time, we create a new version of the document that now contains two ranges. A record that contains a list of text ranges is called an EDL, or Edit Decision List. The term comes from cinematography. Now let's see how deletion works. Suppose we want to delete a portion of text. First, we calculate the ranges of text that surround the selected part. Then we create a new version of the EDL with those new ranges, excluding the part we want to remove. As a result, that piece of text no longer appears in the document. However, the text itself still remains in the content file. The reason we keep everything in the content file is that we want to stabilize content addresses. Every character in that file has an index, and those indexes should never change. But what if we really need to remove something from the content file? For example, what if some sensitive information was accidentally added and shouldn't be stored there at all? There is a way to handle this without breaking content addresses. Instead of deleting the text, you replace it with another text of the same length. For example, you could replace it with a sequence of emojis. Now let's see how stabilized addresses help with floating links. Here we have two documents connected by a floating link, which in Project Xanadu would be called a Xana link. For now, we'll focus only on the left side of the link. Let's say it covers content addresses from 11 to 90. No matter how document A changes over time, the link will always remain attached to that range of text. Suppose new text is inserted in the middle of that range. When text is added inside an existing range, the original range splits into two parts. As a result, the left side of the link will have two ends. Next, let's remove the text from addresses 31 to 60. One of the ends of the link becomes smaller. If we then remove the text from 61 to 100, one of the ends disappears entirely. If we delete all the text that the link can connect to, then the link disappears completely in document A. So link ends can change. They can shrink, split into multiple parts, or disappear entirely. However, because Project Xanadu preserves all versions of documents, you can always go back in time and see what the link originally referred to, even if it no longer connects to the current version of the document. Another key feature of Project Xanadu is transclusions. Let's say we have two documents. If they have some content in common, the client app can detect that. It can actually visually connect the parts that have the same addresses in two documents. It looks like a Xana link, but it isn't. The difference is that a Xana link is explicitly included in the document, which in Project Xanadu would be called Xana doc. Here I simplified the format of the Xana link. The point is, you include those links into the document. Transclusions, on the other hand, require no explicit inclusion. The client app or browser automatically discovers them using content addresses. To make it easy to distinguish Xana links from transclusions, we could, for example, always render transclusions in green. You might be wondering, are transclusions really necessary? How would people actually use them? Let's look at one use case where transclusions are clearly practical and valuable. Think of how books are published. Specifically, let's look at how new editions are released. Let's say there is an author who publishes the first edition of his book. And let's say the book is priced at $20. His audience buys that book. Then later he releases the second edition. Let's say that the new material comprises only 10% of the entire book, but the book is still priced at $20. How many people who bought the first edition will buy the second one? Probably not very many. And there is another problem. Even if you buy the second edition, how do you know where the new parts are? Are you supposed to just read the entire book from cover to cover again to make sure you have seen the new parts? This system is very inefficient. The audience is missing out on updates, and the author is losing money because he can't effectively monetize his existing audience, the people who are actually interested in his book, since they bought the first edition. How can transclusions help here? This time, the author publishes his book on a Xanadu-like publishing platform. The book is still priced at $20. The audience buys and reads the book. Then, the author publishes the second edition. The audience can open it right away. The parts that are green, they can see. Those are the parts they paid for previously. But there are new parts that are currently replaced by some gibberish. They are not encrypted, by the way. It's just a placeholder. The actual content for those parts is not yet downloaded. Because the new content is about 10% of the book, let's say it's priced at about $2. A lot of people who bought the first edition will buy the second edition and read it. And because transclusions show them where the old material is, they can scroll to all the new parts and read only those sections. In this scenario, everybody is happy. Earlier, when talking about stabilizing content addresses, I showed examples that used only one server, but originally, Xanadu was designed as a network of computers. It was modeled after fast food franchises. Nodes in the network were called silver stands. They were supposed to be physical places where you could go and read documents on computer screens. Today, we would call such places internet cafes. Over time, with the advent of personal computers, those silver stands would also become points through which users could connect to the entire network from their homes. In effect, they would turn into something similar to what we today call ISPs, or Internet Service Providers. Addresses in the Xanadu system, also called tumblers, were supposed to look something like this. They would never change, and they could be infinitely extended. They would include things like the ID of a server, the user, the document and its version, and an index within that document. So the content files used for storing text and stabilizing content addresses, which I showed earlier, would be distributed across many different servers, and the absolute content addresses would be quite long. By publishing anything on Xanadu servers, you would agree that other people can create derivative works based on your content. In other words, they could transclude your content into their documents. Let's look at an example. Suppose you publish a book. I buy your book and read it, but I'm not happy with the ending. I can create my own version of your book with a new ending. Then I can sell my version of your book. Because most of the content in the new version was created by you, every time somebody buys my version of the book, you receive the majority of the proceeds. I am only paid for the ending that I added. A user who buys my version of your book can also open the original version. They will see most of the content because they have already paid for it. But the original ending will be replaced with nonsense text. They can buy that part from you. Is transcopyright a crazy idea? Why would anyone agree to it? What's important for this idea to work is that you don't simply allow people to use your content however they like. You only allow them to use it by reference. That means that every time somebody buys a document containing your paid content, you get paid. And every time somebody reads a document that includes your free content, they will see the source of that content. The idea of two-way links is simple. If you're reading a document and other documents link to it, you may want to know about them. In other words, you want backlinks to the documents discussing the one you are reading. If we are talking only about ordinary hyperlinks, then in many cases, simple comments serve the same purpose as two-way links. With visible connections, the situation is different. What matters is which document contains the connection information. A one-way link works like this. If you open document A first, you can follow the link to document B and see the visible connection between them. But if you start with document B, you cannot get to document A, and you will not see the connection. With a two-way link, you can start with either document. If you begin with document A, you can open document B and see the connection. If you begin with document B, you can open document A and see the same connection there as well. Let me show you an example of a one-way link. You can see two documents visibly connected, but those connections are stored in the left document. If you open the second document in a separate tab, you can see that it's just a web page that has no idea anything is trying to connect to it. If there were a two-way link between those two pages, you'd be able to open the second document, and from there, find the first document. In my app LZ Desktop, I can imitate two-way links. Let me show you. I download the main document. Now I download the secondary documents. Now I open them side by side, and I can see visible connections. Everything works just like in the browser. Let me close the reader. Now, if I open the secondary document, it is shown on the left. I can still see the visible connection to the main document, which is now shown on the right. And the arrow in the middle of the screen shows that the link actually belongs to the document on the right. I can swap the documents by pressing the arrow. From here, I can open another secondary document and swap the documents again. This way, I can follow connections in any direction. It only works because the app has saved all the documents and all the connections. In the Xanadu system, similar navigation would have been possible directly in the browser. Okay. Now let's move on to the second part of this video. How can we build something like Xanadu today? First of all, where could we build it? We've already discussed that it can only be a part of the web, not a replacement for the web. We also discussed that Xanadu was originally designed as a network of computers, but that was in the 1960s, before the Internet. Now that we have the Internet and the web, with its addressing system based on URLs, we don't need to create a network of computers from scratch. And whatever addressing system we use will probably need to be based on URLs. Technically, a literary system could be just one big website, kind of like a social network. The problem with doing it this way is that you would basically ignore all the existing content on the web. And no matter how big your one website becomes, it wouldn't change much. So apparently, our new literary system has to include many websites. The only problem with that is that certain features of Project Xanadu would be difficult, or even impossible, to implement reliably in such a system. Let's say here we have a few websites shown as circles. Each of them can have two-way links between its own pages. By the way, I'm only talking about visible connections here, not regular hyperlinks. There can also be one-way links between websites, but two-way links across websites won't really work, because the system is decentralized. Decentralized simply means that different parts of the system are controlled by different owners. How could you possibly have two-way links in such a system? You might try to agree with another website owner that you will reciprocate each other's links, but they might refuse. Or they might agree, and then later change their mind. That solution isn't reliable, and it doesn't scale. You could try to centralize the system by creating a few large websites, similar to the way we have a few large social networks that everybody uses. And this seems to be the solution proposed by Project Xanadu. If everybody uses one centralized system, then of course you can have two-way links within that system. But that's a bit like saying the entire web should be reduced to a single social media website. It doesn't feel right. It is also possible to create services that collect links from across the web and present the entire web inside an app. This reminds me of efforts to decentralize the web by Tim Berners-Lee with his Solid project, and efforts to decentralize social networks by Blue Sky with their AT protocol. That is probably the most promising way to enable two-way links across the web. But before building new centralized systems, let's focus on adding new features to existing sites. If two-way links can't be reliably implemented between different websites, that's fine. So, what is the solution? Where can we build this literary system? The solution is not to build some big centralized platform. Instead, we should think of it as upgrading the web. We are trying to bring some features from Project Xanadu into the web. You bring those features to many websites by upgrading browsers. Initially, you can upgrade your browser by installing my Chrome extension, Visible Connections. In the future, browsers themselves could be upgraded to support these features natively. While the upgraded browser makes all the new features available to every website, different websites can choose which features they actually want to use. As a result, there will be several types of websites and web pages, depending on which features they support. The idea is that if someone creates a Xanadu-like website, browsers should be able to support all the necessary features, including two-way links between pages on that site. When it comes to connections between different websites, there is nothing a browser can do to make two-way links automatically available, so connections between websites will mostly be one-way. I divide all possible websites into 4 tiers, from Tier 0 to Tier 3. The circles represent websites, and arrows show visible connections. Notice how they are mostly one-way connections. Two-way connections are possible between pages within a single website. Tier 0 basically includes the entire current web with its HTML pages. Notice how all the connections to Tier 0 websites come from websites in other tiers. That's because regular HTML pages cannot store visible connections. A Tier 1 website is a site that supports HDocs with simple floating links. Those links can create visible connections between Tier 1 sites, or between a Tier 1 site and a site from any other tier. These websites are supported by my browser extension. The next two tiers are not supported yet. Tier 2 websites are small sites, like blogs, that use stabilized content addresses. These sites probably won't be willing to provide granular access to their content. They will stabilize content addresses, but construct their documents on the server side. Transclusions from other such websites may work by copying the content along with its content addresses. These sites will mostly not have paid content, but they may transclude paid content from Tier 3 websites if those websites allow it. Tier 3 will include large websites that essentially act as publishers, serving millions of people. Each of them would do what the entire Xanadu system was originally supposed to do. There is no reason why there should be only one such publisher. There could be many. These websites would support all, or most, of the features of Project Xanadu. However, certain features would not be guaranteed to work across those websites. For example, as we discussed earlier, two-way links may not be reliably implemented between them. Some websites may also be reluctant to share content with others, so transclusions across those sites would not be guaranteed either. This whole way of classifying websites is somewhat loose and arbitrary. In reality, things may play out quite differently. For example, Tier 2 websites may never become popular. As I mentioned earlier, small websites will probably not use transclusions or paid content. They may also be reluctant to store every version of their documents. Because of that, it's not entirely clear why they would need stabilized content addresses. Simple hash-based floating links may already cover most of their needs. On the other hand, a lot will depend on the software that eventually becomes available for websites. If a reliable solution for stabilized content addresses appears, something you can simply install and forget about, then many sites may simply adopt it. In that case, Tier 1 websites could gradually fade away, as most sites upgrade to Tier 2. What makes connections between web pages of different tiers possible is that floating links can have different types of ends. If you think about it, a floating link is an object with two sides. On each side, there is some object, or end. In the future, links may even have multiple ends on each side. But for now, let's keep things simple. Currently, we can connect text to text, text to a point, and a point to text. Point-to-point connections between two collages are not currently supported. In the future, we could simply introduce a new type of link end for pages with stabilized content addresses. This would allow us to connect advanced pages to simple pages, and vice versa. And, of course, it would also be possible to connect an advanced page to a collage. Now let's look at possible document formats. As we discussed earlier, documents in Project Xanadu, also called Xanadocs, contain only ranges of text, not the text content itself. The part of a document that contains those ranges is called the EDL, or Edit Decision List. The idea is that the user would download the Xanadoc, and then the client app would request the actual text using those ranges and construct the final document locally. To use EDLs, we don't need to define a new document type. We can use the HDoc format that I described in the previous video. Usually, an HDoc has a content section that contains HTML content. Let's show it in simplified form. What if, instead of a content section, it could sometimes have an EDL section? In the original Xanadocs, there was also a section called ODL, or Overlay Decision List. This is a list of ranges of elements used for formatting. You see, the content referenced by the EDL is just plain text. To create headers, paragraphs, and other formatting, we can store a list of those ranges along with their types. The client app can apply them to the content, and each range will turn into an HTML element. The list of those ranges is called the ODL. So, if you have an HDoc with an EDL, you will usually need an ODL section as well. By the way, the format for EDL and ODL records is not defined yet, so what you see here is just an approximation. I think that in practice, many documents would get all their pieces of text from the same website, and often there would be only one piece of text. So in many cases, it may make sense to let the server construct the document. This reduces the number of requests. Plus, constructed documents can be cached on the server. To support this, we would need another variant of an HDoc. In this version, the HDoc has a content section with HTML content, but the EDL section is included as well, so that it can be used to calculate the positions of floating links and also for transclusions. The ODL, however, is not needed in the HDoc in this case. Depending on how the data is stored on the server, the ODL may still exist there in some form, but when the HDoc is constructed on the server, the information from the ODL would already be converted into HTML tags, so a dedicated section for overlay information would not be necessary. So we have the original, simple variant of the HDoc, which is currently supported by my extension, and we may also have two additional variants that could be used by Tier 2 and Tier 3 websites. Note that this doesn't mean that one of those variants belongs to Tier 2 sites and the other to Tier 3 sites. Both variants could be used on either type of site. For example, it may seem that a Tier 2 website can only serve pre-compiled documents with a content section because those websites do not allow granular access to their text content. But they may still serve a document without content if its EDL references text stored on another website. On the other hand, a Tier 3 website may sometimes construct certain pages on the backend simply for the sake of optimization, even though it also provides granular access to its text content. Basically, there is no way to tell whether a website is a Tier 2 or Tier 3 site based on the type of HDoc it uses. The difference lies in the type of functionality that each website provides. There is only a distinction between the simple HDoc and HDoc variants with advanced features. It should also be possible for the server to construct the content only partially. Maybe the server has most of the content, but one part of the document is supposed to come from a different website. Or perhaps some part of the content is not free and needs to be paid for. In such cases, the document could include placeholders, parts replaced with scrambled text, and those parts would be requested separately by the client app. Another possibility is to include a special tag inside the HTML content of the simple variant of an HDoc. This would allow us to transclude some content into a Tier 1 document. In this way, you could have the simplest possible HDoc and then retrieve some content from another website, possibly paid content that you would need to purchase first before accessing it. Now let's look at content addresses. The addresses I showed earlier can be modified. Instead of a server number, a domain name can be used. The format of the rest of the address can then be defined by each individual website. Theoretically, we could also use alphanumeric characters instead of only numbers. Here's another idea. Because in many cases documents will be constructed on the server, it may be possible to stabilize content addresses without actually storing the content in a separate content file. Some websites could store the content directly inside documents and simply pretend that a content file exists. Let's say there is an imaginary content file called 1.txt. Then, this is how a range of text in that file could be addressed. To add more and more content, somewhere on the server, you would need to keep track of the total length of the content in that imaginary file. Let's say you don't want to do that. Then you could simply create a new imaginary file every time new content is added. But now you would have to keep track of the number of files. Let's say you don't want to do that either. Then you could use large random numbers as the names of imaginary files. This way, we not only avoid storing content separately from the document, but also eliminate the need to store any additional information. the content remains inside the HDoc. And if somebody wants to transclude it into their document, they can copy both the needed content and its addresses from the HDoc. That's another thing worth noting. If two documents share some content, it doesn't necessarily mean that the browser has to download it from the same place. The same content can be stored on multiple websites. Let's say we have two documents from two different websites. Imagine that each site uses a single imaginary file, so absolute content addresses may look like this. Document B may transclude a part of document A simply by copying that part along with its content addresses. The client app only cares about the content addresses. If it sees the same addresses, it will visualize a transclusion. Whether the documents were assembled locally or downloaded with all their content from two different websites doesn't really matter. Now let's look at how micropayments can be implemented. It may seem that micropayments are something strange. Imagine payments that are fractions of a cent. How would that even work? In reality, it's actually very simple. Paid content will mostly be provided by large Tier 3 websites. Such websites will have a regular HTML page where you can go and top up your balance. That part is already solved. There is nothing complicated about it. Once you have funds on your balance, micropayments are just database operations. You don't have to call Visa or MasterCard for every small transaction. You simply need to keep track of who owns what content. So, how exactly would those payments work? The parts of the content that are not free may be replaced with some placeholder text. And there may be a standard button for purchasing that content. An HDoc can also have a special iframe on the side. That iframe can load a page from the same website. That page would be responsible for communicating with the website's backend. The HDoc and the iframe can communicate with each other. What I can do is develop an API for that communication. The API would define a few simple methods. For example, when the page loads and there is paid content, the main process can send a special request through the API to the iframe. That request would contain the addresses of the content in question. The page inside the iframe would then communicate with the server and provide a response. It might respond that the user is not logged in. In that case, the UI could show a login button next to the part of the text that is currently hidden. You will log in using the iframe. After talking to the server, the iframe might respond that the content has not been paid for yet, so the HDoc would show a pay button. You press the pay button and a message is sent to the iframe. What happens next depends on how the web page inside the iframe was programmed. There may be a payment pop-up, or it could simply be a one-click purchase. After the purchase is completed, the iframe retrieves the content from the server and sends it to the main process. With this approach, I don't need to worry about the details of the purchasing process. I don't care how the iframe talks to the server or what authentication method it uses. I only need to define an API for communication between the main page of the HDoc and the iframe. That API could become a web standard that browsers and other apps implement. To test the API, I don't need to implement real purchases. I can simulate them by making the web page inside the iframe send whatever responses I need. By the way, this arrangement with an iframe on the side is what I plan to implement in my browser extension. Once browsers support HDocs natively, a separate page in another tab could be used instead of an iframe. Or some completely new UI could be introduced, perhaps a pop-up with an iframe inside that appears only when needed. Extensions have a limitation when it comes to iframes. The iframe has to load a page from the same website that served the HDoc. Because of that, including paid content from a different website in an HDoc will not work. Once HDocs are fully supported by web browsers, that limitation will be removed. As we discussed earlier, two-way links between websites are tricky, if not impossible. So we need to focus on supporting two-way links within a single website. If we have two pages on the same site, and one page has a connection to another page, then to make it a two-way link, the website only needs to insert a reverse connection into the second page. Notice how the second connection references the first page and how the two ends of the floating link, which I marked with different colors, have switched places. The only problem is that now it's not clear which document owns the connection or which document is commenting on the other. So perhaps there should be some indicator showing whether a connection is incoming or outgoing. I may add something like that in the future. Another issue appears when a page becomes popular and has many incoming connections. Should the website show all of them or filter them somehow? Another possibility is to use the comments functionality to list all the pages that have connections to the current page. That's where the website could try to rank and sort them. Each comment could include a link to the corresponding page and possibly a short description. By the way, in the future, comments will also have the ability to create visible connections to the main content, so that mechanism might also be used to show incoming visible connections. Another possibility would be to design a new UI solution and perhaps introduce a dedicated section in the HDoc specifically for incoming connections. This is something to think about. Enough of the technical details. Let's summarize everything with a simple metaphor. Imagine a buffet. But this buffet is not for people. It's for websites. The people in the picture represent websites. And instead of food, this buffet serves the features we discussed in this video. Features like visible connections, stabilized content addresses, versioning, transclusions, two-way links, micropayments, and so on. The buffet table itself represents the client app. In the future, it could simply be a regular mainstream browser like Chrome or Safari. For now, it has to be a browser with the Visible Connections extension installed, or my app LZ Desktop. Websites come to this buffet and take whatever features they want. There are also trays. The trays represent back-end software. For example, right now, we have a WordPress plugin that many websites can use. Some websites may even bring their own custom-made trays. In some cases, such trays will allow those websites to take everything offered at the buffet. Those sites will be Xanadu-like publishers. Also, any website can grab food without a tray, because you can always create an HDoc manually and upload it as a file to your server. You don't need any special back-end software for that. And of course, all of this is voluntary. Some websites may never visit this buffet. So if we are building a buffet, where exactly are we in this process? I would say the buffet already exists because we have the extension. It's just not popular yet, and it has a very limited menu. Currently, it serves only simple visible connections. So what we should do is popularize this buffet in its current form, and then, when we start seeing traction, I can add advanced features. There is no rush to add those advanced features. But if visible connections ever go viral, it would be better to already have those advanced features implemented in the extension and being used on the web before mainstream browsers begin supporting visible connections natively. It would be much easier for browsers to implement advanced functionality if that functionality already exists and is being used by many websites. Otherwise, they might simply support visible connections and later refuse to add more advanced features because those features may seem too niche. I think I could develop all the advanced features in about a year, but I don't know when I will be able to start. As I mentioned in the previous video, because of my financial situation, I may have to pause work on the project for some time. Even promoting simple visible connections may have to be postponed. But when I actually start implementing advanced features, what will it look like? Where would I even begin? I think the best place to start is a text editor that can work with stabilized content addresses. This kind of editor would allow transclusions, and all the text would be shown in patches. Whenever you add new text, it creates a new patch, possibly splitting an earlier patch of text. I will build it into my app LZ Desktop. The app already supports connections between documents and simple document editing. I will simply add a new type of text document that stores ranges of text, while the text itself will be stored elsewhere. This type of text editor will allow you to collect different materials and then transclude them into the final text. Earlier, I talked about how transclusions may be useful for publishing new editions of paid content. This editor is another example of where transclusions may be useful. Writers may benefit from using transclusions even if, in the end, they simply merge all the patches and export the result as plain text. Building this text editor will inform my decisions about how to present advanced features in the UI and how to represent them in the HDoc format. Then I can add new features to HDocs, publish those HDocs on my local site as files, update my extension, and test everything against those files. Later, I can work on back-end software to help websites adopt the new features more easily. I could upgrade my WordPress plugin or create a completely new content management system that supports stabilized content addresses. I could even build a toy version of Xanadu just to demonstrate the technology. It wouldn't be that hard, especially if you don't plan to scale it to millions of users or implement a full royalty system. And I will open source all of that, except, perhaps, the desktop app. If you found this interesting, consider liking the video and subscribing to the channel. You can also visit my website, reinventingtheweb.com, for contact information and links to my social media to stay updated on the project. Thanks for watching.